Okay, hello everyone. Now I'd like to make a video on the chain rule. So what the chain rule does is it allows you to take the derivative of compositions of functions. So if h of x can be written as f of g of x, then what the chain rule tells you is that the derivative h prime of x is going to be f prime of x with g of x plugged in times g prime of x. And like colloquially, I always just say it's the derivative of the outside function, and you plug in the inside function, leaving it alone, and then you multiply by the derivative of the inside function. It's kind of like this chain of derivatives and multiplications. Alternatively, if you can write y as a function of u and u as a function of x, then the chain rule says that dy dx is the product of dy du times du dx. And I'll show you how this works in an example in both ways. So let's start with decomposing this as f of g of x. So h of x is the square root of x cubed plus 7, and we want to decompose this as f and g. So first I'll do g. G is easier probably to see because it's the inside function. So I'm going to write that as x cubed plus 7. And then what's left over? Well, there's that square root sitting outside. So I call that f of g of x. That would be the square root of g of x then, where g of x is x cubed plus 7. Or a lot of times I just write that as f of something is the square root of something. Okay, so when I do that, then I know I'm just decomposing this as h of x is x cubed plus 7, and I have the blue is f of something, and the green is the g of x, which is x cubed plus 7. So now when I go to take the derivative of h prime of x, I know that I should take the derivative of the outside function, plug the inside function in, and then take the derivative of the inside function and multiply by that. So here I go. The derivative of the outside function is going to be 1/2 something to the negative 1/2. I plug in the something, which is x cubed plus 7, and then I multiplied by the derivative of that something. Derivative of x cubed is 3x squared. The derivative of 7 is 0. So then I now just simplify a little bit. I can make that x cubed plus 7 to the negative 1/2. I can make that x cubed plus 7, 1 over x cubed plus 7 to the 1/2, or 1 over the square root of x cubed plus 7. And of course, that 1/2 out front gives me the 1/2 sitting in front of that square root of x cubed plus 7. Then I multiply by 3x squared, which was the derivative of g of x. And of course, 1 times 3x squared is just 3x squared, so I'll delete that 1 now. Okay, so that's the first method. The second method is to decompose this as y as a function of u, and then u as a function of x. Sorry, yeah. So we're writing y as x squared of x cubed plus 7. So u will be the function of x, which is x cubed plus 7. And y will be the square root of u. So then dy du should be, actually I'm going to change my colors here. Du dx is going to be 3x squared. And dy du is going to be 1/2 u to the negative 1/2, which you can simplify as 1 over 2 times the square root of u. Okay? And then the rule is pretty simple because it almost looks like fractions canceling. You say dy dx is dy du times du dx, and it almost looks like the du over du is canceling. So that's one way to remember this rule. So now I just plug in dy du. Well, that's 1 over 2 square root of u, and I wrote that in the wrong color, so I'll go back and write that as 1 over 2 square root of u in red. And then the blue part is 3x squared, multiplied by that. I'll simplify. And the only hard part here is you have to remember to plug that. So the same answer, so times the square root of x cubed plus 7 times, and that's it. Thanks for your time.